Welcome to the next lesson in this chapter, where we are going to talk about the event notifications pattern from event-driven architecture. If we jump into the code and open up the order entity, which is defined in the ticketing module, we will be able to see a few examples of the event notifications pattern. If I take a look at the create method, you can see that we are creating the order for the specified customer, but we are also raising the order created domain event. If I take a look at this domain event class, you can see that it implements the domain event base class that we discussed in depth while implementing the outbox pattern, and you can see that all we have on the order created domain event is the order identifier property. Now, if I go to the application layer of the ticketing module, and open up the orders feature folder, we can see the create order use case. Inside of this folder, I have a few domain event handler classes that all handle the order created domain event. The first handler that I want to look at is the order created domain event handler. This is a typical use case for the event notification pattern where we publish a specific event, in this case an order created domain event, and also note that this is a fin event. It only contains the order identifier, which we can then use to get the order details response. Once we have the order response information, we can publish a more detailed event, which is the order created integration event that contains the customer information, the total price for the order, as well as the information for the individual order items, which are mainly which ticket type was sold and what was the price that it was sold at. However, we also have additional handlers for the same domain event. So if I take a look at the create tickets domain event handler, you will see that here we are taking in the event notification type, which is our order created domain event, and using it to send a create ticket batch command. So this is triggering behavior in a temporally decoupled way. We can place the order inside of the order placement flow, and then asynchronously we can publish our domain event, which is going to trigger the create ticket batch flow. If we take a look at the respective command handler, you can see that we are fetching the order from the database, calling the issue tickets method on the order, because we can only issue tickets for a given order once. And if this succeeds, we're going to take the tickets that we have on this particular order using the order items, and we are going to create the tickets for this order. You can imagine that this can publish more event notifications, which can trigger other behavior inside of our system. And then let's take a look at the last domain event handler for the order created domain event, and this is the send order confirmation handler, which is just going to take in an order, and once we have the order details, we can send an order confirmation notification. This could be an email being sent to the customer, or it could be a real-time notification sent using SignalR, for example, Firebase messaging, or something similar. As I said in the previous lesson, the main use case for the event notification pattern is communication inside of an event-driven architecture. We are publishing the order created domain event, and this is communicating with the respective handlers inside of our application, which trigger further behavior. This pattern also allows us to implement temporal decoupling, which can help us to simplify our use cases. What I really like about this pattern is how it can allow you to easily add new behavior into your system. If we take a look at the users module and the registered user use case, right now we only have one domain event handler for the user registered domain event. This one is going to publish the respective integration event that we are going to discuss in the next lesson, but imagine how easy it would be to introduce an additional domain event handler handling this same domain event that can do something simple like send a welcome email to the newly registered user, and we could also use this to implement an email confirmation flow for a new user. I also wanted to make a remark about actually sending your notifications. You will see some implementations where we have a dedicated component, and it could even be an independent module that will be responsible for sending notifications. The downside to this approach is that you will have to send messages to this module or component, and then it's going to trigger sending the email or the real-time notifications. And these messages sent to a notification service or module would need to contain all of the required information to send an email to the customer, for example. An alternative could be for the notifications module to query the module that owns the required data, and then, for example, it can gather the necessary information from multiple modules before being able to send an email. You can imagine querying the users module for the user information, the events module for details about a particular event, and then the ticketing module for information about the customer's tickets. And instead of implementing a complex system like this, consider if it would be simpler to have just a dedicated email sender class that you could inject inside of all of your modules, and then the respective module probably contains all of the information it needs to send a specific email. In case of the ticketing module, we already have some information about the customer, and we have all of the information that we need about the customer's order and tickets, and it would not be complicated to implement email notifications directly as part of the ticketing module. Hopefully, this should give you something to think about as we wrap up the discussion about the event notifications pattern. In the next lesson, we are going to talk about the event carried state transfer pattern. Welcome to the next lesson in this chapter, where we are going to talk about the event carried state transfer pattern. This pattern allows you to implement data distribution inside of an event-driven architecture. And I think that the best way to understand event carried state transfer is with an example. So let's take a look at the user registered integration event. This integration event is what we call a FAT event because it contains a lot of additional information that's mainly used to distribute data inside of an event-driven architecture. Other than the user identifier, which is probably the most important property on this integration event, we also have the user's email, first name, and last name. If we take a look at the respective domain event handler for the user registered domain event, you can see that we are using an event notification, which is our domain event, to obtain additional information about the user and then use that information to publish a more detailed event, which is our user registered integration event. And we use this integration event to implement event carried state transfer. The name of this pattern is derived from the fact that we use events to carry a specific piece of state of our system and then transfer that to the other components in our system that are interested in storing this state. Now, if we take a look at the respective integration event handlers for the user registered integration event, you can see that they are taking the information available on this integration event about the user and persisting that locally inside of the respective module. In this case, we are in the ticketing module, and inside of this module, the user becomes a customer, even though this is conceptually the same entity inside of our system. We also have another handler for the same integration event inside of the attendance module, and this time we are using it to store the user's information as an attendee entity in the attendance module. Let me show you what this looks like when we start the application. We are going to trigger the event carried state transfer inside of our system by registering a new user. So I'm going to send a post request to the Evently API that's going to register a new user in our system, and this is going to kick off the event carried state transfer. So I'm going to hit send, and you can see that our request completes, and now we have to wait for our background job, which is processing the outbox messages, to pick up the user registered domain event. And you can see that we hit the breakpoint inside of the respective domain event handler, which is going to go ahead and publish the user registered integration event. So I'm going to hit continue, and we land back in Postman, but I'm going to go back to Visual Studio, and now I'm waiting for the background job processing the inbox of the respective attendance and ticketing modules, and eventually it's going to pick up the user registered integration event. You can see that we also landed in the respective handler in the ticketing module, and now we can go ahead and invoke the individual commands. So here I'm sending the create attendee command, and here I'm sending the create customer command. Both of these commands are going to complete, and we will end up duplicating the user data across the attendance and ticketing modules. So I will hit continue. Our entire flow is going to complete. You can see here that we are wrapping up the execution of the create customer command. I'm going to hit continue as well. And now let's take a look at the database and see what we have inside. If I open up the users module and we take a look at the users table, you can see that we have our new customer right here with the email that we specified when I sent the request to register a new user. Now, if I copy the value of this identifier and head over to the ticketing module database and open up the customers table, and I do a simple filter by this identifier, you can see that we do have a record in the customers table with this identifier, which is the record that we duplicated in the ticketing schema using event carried state transfer. We also have the same in the attendance module. So let me take a look at the attendees table, and if I apply a filter by the identifier value, you can see that we have the same record also present in the attendees table of the respective attendance schema. As you can see, event carried state transfer is an interesting pattern to implement inside of an event-driven architecture because it allows us to make our modules inside of this modular monolith example decoupled from each other because they do not need to query other modules in our system for any data that they require. The downside to this approach is that we have to deal with eventual consistency, as there is a given period of time from when we publish the actual integration event inside of the users module until the respective integration event is consumed inside of the ticketing module, and we create a copy of the customer record, as well as creating a copy of the user as an attendee in the attendance module. Regardless of how fast our messaging system is, the attendance and ticketing modules are always going to work with a stale copy of data of the user record from the users module. And this is probably acceptable for some business use cases, but there could be other use cases in the system that cannot work with stale data, and in that case it's completely appropriate to query the module that owns the data so that you can get the most up-to-date information to make your business decision. And with this, I'm going to finish up our discussion about the event carried state transfer pattern, as we have already talked about it in length in all of the previous lessons inside of this course. For example, when we were implementing communication between our modules using messaging, or when we were talking about the outbox and inbox patterns. So I don't want to repeat myself too much, but it was important to place a name on the approach that we were using, and this is called event carried state transfer, and it's one of the core patterns of event-driven architecture. In the next lesson, we're going to discuss materialized views and CQRS.